Okay, hello everybody. We are going to go over 6.K8.1, which is calculating the average rate of change. Okay, so we're going to be talking about rate of change, which is something we've done before, but this time we're really focusing on the idea of an average rate of change. Okay, so it's kind of like the middleman of the rate of change. It's not the exact rate of change, but it's an average of what's happening between certain points. Okay? And we know that quadratics are not linear, so their rate of change is not a slope, but it's a rate of change that's changing between every single point. That's what creates the curve that keeps expanding as you go. Okay, so here's our projected object graph again that we've kind of been looking at multiple times. X is the time in seconds, and y, or f of x, is the height up here. Okay, so we're going to talk about how to calculate it a couple different ways. The first is from a graph, right? So it says to find the average rate of change over the interval 4 to 7. Okay, so remember we've talked about intervals before. That's how you've been writing your positive, negative intervals, your increasing intervals. Those are always x values. Okay, so I want to make a note that these are x values. Okay, so we can find these x values on the graph. So we want to go from 4, so 1, 2, 3, here's 4. All the way to 7. So 5, 6, 7, that's here. This is the interval that I'm looking at, for my average rate of change. So you need to find the points that correspond on the graph with these x values. So let's go up on the graph, and we've got a point. The maximum point here is 416. And then the point that goes where x is 7 is here at 7, 7. So that y value for that is also 7 there. Okay, so those are the 2 points we're going to find our average rate of change in between. And so doing this graphically, that's our first one. You're just going to do this kind of how you're used to, by finding your rise and your run between those 2 points. So find your rise and find your run between the 2 points. So let's go to our graph. Always start with the one on the left. So from the 416 to get down to that 7, 7, I need to go down. So let's count how many boxes I need to go down. And then how many I need to run to the right. So I went down 1, 2, 3, 4, 5, 6, 7, 8, 9. So remember, when you go down, you're negative. So my rise is -9 there. And then my run, I'm going to the right, so it's going to be positive. 1, 2, 3. So +3 there. Okay? So my rise, and remember you divide them. Rise in the numerator, run in the denominator. My rise was -9, and my run was 3. So of course we can simplify this. -9 divided by 3 is -3. So that is my average rate of change for in between 4 and 7. So specifically between those 2 points there. On average, it's changing at a rate of -3, so decreasing by a rate of -3. Now, the rate of change between any points in this interval, like from here to here or from here to here, it could be anywhere below or above that average value. Okay, let's talk about how to do this algebraically. So algebraically, we're going to do the same thing over the same interval, but I'm just going to show you how to do it without the graph. Okay, so since we know that the x values are 4 to 7, we would need to solve for what that y value is if we didn't have the graph. Okay, so you can use this. You're going to evaluate your equation. So algebraically, we're going to find the values of f of 4. See, I'm replacing x with 4. That's the first x value of our interval. And so everywhere in our equation, we're going to replace x with 4. So rewrite the equation. So negative, instead of x, I'm going to put 4. And then continue writing. So -4 squared. And then plus 16. Okay, and then from here, we just simplify the expression. Okay, so remember parentheses goes first in our order of operations. So we're going to simplify what's inside. So 4 minus 4 gives us 0. So this is going to be a -0 squared plus 16. Then we do exponents. That's the next order of operations. So 0 squared is just 0. So this would be a -0 plus 16. Now we don't really have a -0. So that's just -1 times 0, which is 0. So then 0 plus 16 would just be 16. Okay, so that's a coordinate, and since we have the graph, we can confirm that when x is 4, f of x is 16. That's what the graph shows us. So what we're going to do is we're going to put this coordinate in the table over here, 4, 16, so that we have our first point to go off of. So now we need to solve for when x is 7, what's our y value, by doing the same thing. So instead of replacing x with 4 this time, we're going to replace x with 7, and that comes from our interval. So we're finding f of 7 this time. Everywhere we see an x, we're going to replace with 7. This is negative 7 minus 4 squared plus 16. And then simplify. Similar process. Let's simplify what's inside the parentheses first. 7 minus 4 is 3. Okay, so then we're going to do the exponents. So 3 squared is 9, but don't forget that that negative is in the front. That multiplication comes after you square, so you must keep that negative in the front first, because positive 3 squared is 9. Okay, plus 16. Okay, so then last but not least, we've got negative 9 plus 16, and this is going to give us positive 7. Okay, so it says when x is 7, that means y is 7. And if we go and look at our graph, that coordinate is confirmed, 7, 7. So let's put that into our table here. Okay, so then once you have those two coordinates from your algebra, then you can find your rise and run from a table, just like we've done before. Find your change in y. So to get from 16 to 7, we're going to have to subtract 9. And then on your change in x over here, to get from 4 to 7, we need to add. We're going to add 3. Okay, so then same thing. That's your rise and that's your run. Your change in y is the same thing as your rise, and your change in x is the same thing as your run. So then we would divide them. Delta y over delta x is negative 9 over 3, which simplifies to negative 3, which is the same thing we got. So we were doing for the same function, just in different ways. Okay, so now a lot of times you'll be asked to interpret this, especially if you're finding the average rate of change of a quadratic in context, like on our launch problem, or anything that is representing some sort of projectile motion. You'll need to explain, like, what does that mean? Why do I care about the average rate of change there? So here's a sentence stem to get us thinking about what this average rate of change means. So to start, you would say from this x value to this x value. So we did from 4 to 7. So we would say from 4, that's our first x value. And what does this x value mean? What are we measuring in on the x-axis? We're measuring in seconds, okay? So from 4 seconds to, so the next x value, that's your end point on your interval. We ended at 7. From 4 seconds to 7 seconds. The whatever object you're talking about, whatever's being launched, or if we're talking about flu season or coronavirus, that's what you would say. So here our graph doesn't really represent anything, so let's just say the projected object is, now you pick, is it increasing or decreasing here? So we can look at our graph. This part of the graph here, from this point to this point, we are going down from left to right. So it is decreasing. We also know that because our rate of change is negative. So we would pick it is decreasing. So we can make a note. This is if you've got a positive rate of change. I'm abbreviating rate of change, ROC. This is if you've got a negative rate of change. Okay, so we're decreasing at an average rate. This is super important because you're not decreasing at this rate every single time. This is just a way to describe it on average between those 2 points. So including that in your interpretation is essential. So we're decreasing at an average rate of 3. What's our Y units? 3 feet, because that's what's happening. Over time, we're either increasing in height or decreasing in height. So 3 feet per second, right? That's our X unit. Okay, a lot of times people ask, okay, so why did I put a positive 3 and not a negative 3? And that's because I already said that I'm decreasing. If I said I'm decreasing negative 3 feet, that's kind of redundant. Since I already said I'm decreasing, I can use the positive 3. And so if you're increasing, you would just say I'm increasing negative feet. It still makes sense to say I'm decreasing 3 feet per second. Okay, well, that's all we've got. So just make sure you've got these copied down in your notebook. Maybe you were able to print this off, and make sure you keep it in a safe place so that you've got it when you've practiced.